Hey everyone, my name is Steven and I'm one of the instructors of Learners Academy, and today I will be taking you guys on a journey regarding prerequisites and review for this chapter, which is chapter 4, curve sketching. So this video will equip you with all the skills and exercises that you need in order for you to get ready for the actual chapter 4. With the first practice questions, we will be reviewing a little bit more about polynomials and how to solve these equations. So the first equation gives us 4x squared minus 9 equal to 0. So by the end of this calculation, we want how much x equals to. So we put 9 to the other side of the equation, which becomes positive, and we divide 4 to the other side. That will also leave us with 9 divided by 4, which if we simplify it, that will become 3 divided by 2. Then we will put the square root, and then if we actually put it into calculation, we will get ourselves 1.22, and that's the final answer. Okay, so let's go to the second question. The second question gives us 2y squared plus y negative 3 equal to 0. For this question, we cannot handle and approach the way that we did with the first question. We have to use what we call a cross method. So before doing our cross method, we have to figure out things that we can learn from just looking at this equation. So we have the ending number, which is 3, and the coefficient of y squared, which is 2. Alright, we will be factorizing these two numbers. That's one. And then another thing is we look at these signs. This signs, because it's minus, it means that if we factorize these two numbers, we have to subtract them. And then this plus gives us information that, okay, if we subtract it, we have to have positive as a greater number, positive 1 as a greater number, because there's 1 in front of y. So that's what we have concluded from this equation. So let's put it into cross method. So when we think of, okay, let's start with 3 first. When we think of factoring 3, there's only one alternative to factor 3, which is 1 and 3. Okay, and same goes to 2 as well. If you want to factor it, there's only one way, which is 1 and 2. But we have to be mindful that by looking at these signs, we know that we have to subtract these two values, and then the resulting value should be positive, and it should be positive 1. So I'll put 2y here, and then y here. Okay, so let's put, this is 3y because we multiply 3 and y, and then we multiply 2y and 1, which will give us 2y. Right? So we know that we have to subtract these two numbers, 3y and 2y. And the resulting answer will result in positive y. So I'll write that down real quick. So in which way will we get positive y if we subtract these two values? And if we think about it, if we put plus in front of 3y and if we put negative 2y, we will get exactly this answer, which will leave us with positive here and a negative here. So we got two equations from this single one equation, and we can write it down to y minus 1 into 2y plus 3 equal to 0. And we separate those two equations, y minus 1 equal to 0, 2y plus 3 equal to 0. That will leave us with the answer y equal to 1 and y equal to negative 3 by 2. And that's it. Alright, let's move on to the next question. This question is the same. We have to solve this equation, but the difference is that now we're dealing with the degree of 3. Which means that we can use the same approach that we did with the two previous equations. So firstly, we have to figure out what factor will we be able to use in order for this whole equation to turn 0. Which means that which number should we substitute in place of x so that this whole equation will equal to 0. So factors of negative 10 can have so many alternatives. Say it can be plus or minus 1, or plus or minus 2, or plus or minus 5, and the rest goes on. This is merely just a way, like a format of how to write it down. And then to guess and check, we have to figure out which number will result in the whole equation turning to 0. But before that, I would like to put this equation into a function. So let function of x equal to x cubed plus 6x squared plus 3x minus 10. Alright, so to guess and check, we will figure out, or you can put it in a scientific calculator as well. So we will first figure out the first factor or the first number that we can use to turn it into complete zero. So 1, 6, 3, and -10. Alright, the first number is -5. Let's put that into test, shall we? So if we actually put the -5 in place of x, if it's actually the factor of this equation, the result will end up in 0. So -5 cubed plus 6 into -5 squared, and then plus 3 into -5 minus 10, which resulted in 0, which means that x plus 5 is a factor of f of x. F of x. Okay, so we have already figured out we've already figured out the first factor of this equation. So to find the rest of the equation, we have to divide this factor with the whole original equation. Okay, so x cubed plus 6x squared plus 3x minus 10, and then x plus 5. X squared, x cubed plus 5x squared, and then we subtract these two numbers, x cubed minus x cubed, which result in 0, and this will result in x squared plus 3x, and then plus x squared plus 5x, and if we subtract these two numbers, x2 will get cancelled out, x squared will get cancelled out, and then this will result in negative 2x minus 10. Minus 10. And to get negative 2x, we have to multiply it with negative 2, which will result in negative 2x minus 10. Which resulted in 0. Okay, so from this we can conclude that x plus 5, x squared plus x minus 2 equal to f of x, or you can just write it as 0. And then using the cross method earlier, we can factorize x squared plus x negative 2 into a smaller two different equations. So 1, negative 2, and that makes us x minus 1 and then x plus 2 equal to 0. And the final answer is x equal to negative 9, or x equal to 1, or x equal to negative 2. So this is the final answer. Now, there's something that I would like to add in this question, and which is this form that is written in a way quotient plus remainder divided by divisor. Okay, so for the sake of the term, this is called divisor, and this is called quotient. And then lastly, this, oh wait, hold on. This is what we call a remainder. So from this division, if we were to write these answers in this exact form, it will result in x squared plus x minus 2, and then plus 0 divided by x plus 5. And we're writing this in this standardized form being framed here. Well, if you actually divide 0 with x plus 5, which will result in 0, which doesn't make any difference. But then if there is a remainder with a natural number apart from 0, and if we are to write it in this form, we have to remember this form and then write it in that way. Because later in this chapter, there will be times where we have to refer back to this form. Alright, so to elaborate more on what I mean by writing the answer in a form, I meant this. So I will demonstrate to you guys another example, which is that we're giving this equation, which is x cubed plus 6x squared minus plus 3x minus 10 equal to 0. And the question wants us to divide this equation using x plus 1. So we don't know whether x plus 1 is actually a factor of this equation. That's not really the matter in this case, but this question only asks us to divide this equation using x plus 1, so we do this accordingly. And at the end, we get a remainder which is negative 8. So now that we have quotient, remainder, and the divisor, we write it in this form. So we first write the quotient x squared plus 5x minus 2 here, and then we plus, and then we put the remainder at the top of the fraction, negative 8 divided by the divisor at the bottom, x plus 1. Okay, so secondly, we will be exploring about how graphs should look like in general based on the number of degree or powers that they have. Okay, before anything, I would like to review a little bit more about the term degree. We write degree in mathematical terms as n. And what does n mean? Say if we have like a function, for example, like x squared plus 2x plus 1. From this equation, we can conclude that n equals to 2 because 2 is the greatest degree that we have in this function. So what does it mean by degree or n? Degree or n means that means the value of the highest power or index that we have in this single equation. So for example, if we are given another function that has x cubed has the highest power or index, that means that n equals to 3, and so on and so forth. So let's start with a polynomial or a function that has the value of n equals to 1, which from this, for example, if we put it into a function, for example, that would be y equal to 2x plus 1. And because the highest index that we have in this function is 1, n equals to 1. So, and then another thing is, we have a positive number in front of this coefficient 2. Positive number. This is positive. Okay, from these two information, we can generally visualize this graph with n equal to 1 as this. It goes upward, it goes inclined. And say for example, if we have if we have a negative number in front of 2x, so we have a leading coefficient of negative, that will result in this straight line doing the other way around, which is a decline or the downward slope. Okay, that's how graphs usually look like with n equals to 1. And then let's move on to n equal to 2. N equal to 2, for example, the function should be, say, like this is the one that I give, x squared plus 2x plus 1. And from this equation, we can learn that the highest index or the highest degree for n equals to 2 because there is x squared with the power of 2. And if we have a leading coefficient being a positive number, the graph will result like this. The graph will result in like a cup. And say, for example, if it has a negative leading coefficient, the graph will result like this. It's a cup, but upside down. Okay, so let's move on to the third graph, which is n equals to 3. Say for example, the function can be something like like 2x cubed plus 5x squared plus x. So we have the highest degree or index being 3, so n equals to 3, and the leading coefficient is positive. And if that's the case, we get the graph something like this. And say for example, if the leading coefficient is negative, we get something opposite, which means that we will get something like this. We go down and then up and then down again. Oh. Down and then up and then down again. So the next slide is we will be talking about the other two important graphs, which is n equals to 4 and n equals to 5. So for example, the function would be x equal to 4. Or for this one, the function would be x equal to 5. Okay, so for this one, if we visualize it in a graph, it kind of looks like a quadratic function, generally. Which means that it goes like a cup again. It goes like a cup facing upwards again, but then we have this, wait. It goes like a cup back again, and then instead of having a sharp turn, we have this long, less sharp turn, and then it goes back up again. This is how generally the functions with n equal to 4 looks like. And then for n equal to 5, it's kind of similar to what we had with the cubic function, which is n equal to 3 as well. That means we have something, we have something like this. So when n equal to 2 looks like this, n equal to 4 looks more like this. When n equal to 3 looks like this, n equal to 5 looks more of like this. But if we tweak it up a little bit, and if we put some other coefficient and variables, the graph will definitely change. So say for example, this graphs, if we tweak it up a little bit more, this can result in something like this. And the same goes to n equal to 5 as well. If we tweak it up a little bit, it can change into something like this. Okay, so if we have a leading coefficient of, this is leading coefficient of positive, and if we have it negative, the graph will definitely turn upside down. And the same goes to this one as well. If the leading coefficient is negative, the same, the graph will turn upside down again. From this, what I want you to know is how the graphs usually look like based on the degree that they have, because later on in the chapter there are some exercises where we have to draw it, so it can work as the way that you can check if the sketch that you drew is actually correct or not. Say for example, if we will be given like a graph, a function with a degree of 2 and tells us to draw and sketch with a degree of 3, we can pretty much tell how it will generally look like. And then we need to know how the increasing and decreasing intervals look like based on the graphs that we are given, which will also be used later on in the chapter for curve sketching. Okay, let's move on to the next part of the prerequisites, and that is finding domain, ranges, and asymptotes. So we are given these functions, and based on that we have to determine if there's any asymptotes at all, and if we really do so, we have to figure out the domain and ranges of these equations. Okay, so let's start with the first question being y equal to 2x plus 1. So if we think about this equation, and with the general idea of graphs that I've shown you earlier, we can learn that this has a degree of 1. Therefore, it is like a linear, and because leading coefficient is positive, it will get something like this. And it has a y-intercept of 1 because, well, it's 1 is here. So generally it looks like this. So if we look at this, we can see that the graph or the function goes infinitely from left to right. That means that there's no asymptotes or there's no restrictions or whatsoever. There is no both vertical asymptotes and horizontal asymptotes. So that means that the domain exists from negative infinity to positive infinity. Or you can write it in a way such that x includes all real numbers. You can use any notations based on your preference. And then for range, it goes the same as well because there is no horizontal asymptotes. We can write it that this function goes infinitely from negative infinity to positive infinity. And that's it. Let's go to the second question. Second question has f of x equal to x squared minus y. And then if we try to visualize it using the information that we learned earlier, since it has a degree of n equal to 2 and it has a leading coefficient being positive, we can visualize it as something like this. And because there is negative 9 at the back, we can assume that negative 9 is a y-intercept of this equation. And from this, we can see that domain, it goes infinitely from left to right. So domain remains the same, negative infinity to positive infinity. But then range, if we think about range, by looking at the graph, we can see that it doesn't really go infinitely from top to bottom, right? Because as we exceed, if we go lower than negative 9, say like negative 10, negative 11, negative 12, there isn't any graphs going on. So negative 9 is the lowest that we can get. So it has a restriction. though it doesn't have like any asymptotes or anything, it kind of still have a restriction because it doesn't go below -9. So from this, we can conclude that the range has -9. -9 to infinity. So it goes from -9 to only upwards up to infinity. It doesn't go any lower anymore. Okay, so that's that. And then let's move on to the other questions. Okay. So these are the part that gets a little bit trickier. We've come to meet rational functions. Rational functions mean basically the functions that has coefficients that are in this kind of form, and then coefficient as like a fraction. So from this one, if we ever meet these kind of like rational functions, we have to be mindful that in order for us to find the asymptotes, what we have to do is we have to equal this part of the function with 0. So x plus 1 equal to 0. And that we will get x equal to -1. That basically means that we have a vertical asymptote as x equal to -1. And then, if we try to visualize this, it kind of in a sense look like this. So vertical asymptote is here at -1, and the graphs go something along like this. Okay, so it never reaches to -1, both from left and right side. So we can't say and we can't conclude that it goes from -infinity to +infinity because there is a restriction in between. Because both of the graphs it approaches -1, but it never reaches -1 at all. So from this, we can say that the domain is -infinity to -1 union -1 to infinity. And if for this one, range is we also have like a horizontal asymptote. And horizontal asymptote is 0 here because there's a line here. Because both of the graphs, just the same with -1, which is vertical asymptote, it never reaches 0 as well. It approaches to 0 both from top and bottom, but it never reaches to 0. And from that, we can say that the range itself is also -infinity to 0 union 0 to infinity. If it's kind of confusing. If it's confusing for you to understand how we get horizontal asymptote equal to 0, it will further be explained later in the chapter as well. But let's move on to the next equation for now. And then again, we're meeting with rational functions again. So in order for us to find the domain, we have to find the asymptote first, the vertical asymptote first. So we equal this part of the fraction with 0, which resulted in 0. So this is our vertical asymptote. And then from this, we can say that the domain is -infinity to 0 union 0 to infinity. And then range. Okay. When it comes to range, the thing that I can explain here for now is that when we have two variables, both from denominator and numerator, that has the same degree, we can put the coefficients into a ratio. Say for example, we have 10x and 5x here. We got x and x, two variables here, which has the same degree, which means that we can put these two coefficients, 10 and 9, into a fraction or a ratio. And from this we will get 2, which means that horizontal asymptote, we get y equals to 2. So from this we can say that the range -infinity to 2 union 2 to infinity. Okay, let's move on to the next part of this review, which is finding derivatives and using differentiation. So before actually solving these equations, something that we have known in advance is that if we Okay, so let's move on to the next part of this review, which is finding differentiation and using derivatives. So before solving these equations, something that we should know in advance is, say we have a function that has an index of n, so x power n. If we use derivative and differentiate this function, what we will get is this index n goes up front as a coefficient of the variable x. So n into x power, this degree of n, it got subtracted using 1. So n minus 1. So if we put this into action and solve this equation, f prime x equal to, we have an index of 2 in this equation. So this 2 got put up front as a coefficient of x, but 3 already exists, so we have to multiply between 3 and 2. That will result in 6. And then x, and then the index of 2, it got subtracted by 1, so 2 minus 1 gives us 1. so x power 1. And then to the next part of it, x has a power or index of 1. And if we put it up front as a coefficient of the variable, 2 multiplied by 1 just gives us 2 the same as well. And then since it has an index of 1, if we subtract it using 1, it will give us an x power 0. 5, since it doesn't have any x, it got removed in the first place. And if we simplify this, f prime of x equal to 6x minus 2, because x that has an index of 0 results in 1. And that's the final answer. Let's go to the second part. The second part is a little bit complicated. For this, to solve this equation, we have to use what we call the chain rule. But before using the chain rule, I want to color code this. Before actually solving this, I would like to color code this for better visualization. So, okay, 3x squared minus 6x divided by 2. Okay, if we want to differentiate this, the index of this equation goes up front, which means that it becomes 2 into 3x squared minus 3x squared minus 6x, and then the index of 2, it got subtracted using 1, so there's only 1 here. And then after that, we have to differentiate the equation inside back again. Which will result in 6x, oh, wait, just 6x and then minus 6. And that's the final answer. It's the same as this one, it's just that we have here x just alone, but then this square here, it is squared by the whole 3x squared minus 6x. Here, the x squared and then x power 1, these are only squared to the x. Here, these are squared to the function 3x squared minus 6x, and then the whole squared. So as a result, just like how we handle the situation here with the 3x squared, we put the index up front as a coefficient of the variable, or in this case, the function. So 2, and then we put the function back again, 3x squared minus 6x, and then the power 2 got subtracted by 1, so 1, and then we have to differentiate the function inside back again, so 6x minus 6, and that's how we use the chain rule. And then we can move on to the next part. Okay, the next part is a little bit complicated, so before that, if we want to differentiate a fraction, what we have to do is use this formula, which is v prime u minus u prime v divided by v squared. So in this case, u is x squared plus 1, and then v is x. And if we find the derivative of u, we get 2x. If we find the derivative of v, we get 1. So we differentiate the whole equation using this formula. So derivative of v prime results in 1 into x squared plus 1, and then minus u prime results in 2x, and then v is x, so x into x gives us x squared, and then v squared gives us x squared here as well. So f prime of x is x squared plus 1 minus 2x divided by x squared. And the final answer is f prime of x equal to 1 minus x squared divided by x squared. Okay, so let's move on to the next part. Okay, so let's wrap things up with this final question about differentiation, which asks us, the function exists such that f of x equal to 2x cubed minus 5x plus 1. Determine the equation of the tangent line to the graph of y at the point where f prime of x equal to 0. So we are given this function, and based on how the function is structured, we have a degree of n equal to 3, and then we have a leading coefficient of positive. That means that generally the graph should look like this. And what does the graph ask? What does the question ask? Determine the equation of the tangent line to the graph of f at the point where f of x equal to 0. If we think f of x equal to 0, before that we need to know that if we differentiate a function, if we find the derivative of that function, we get to learn the gradient of the function at the point of x. Okay, so say we are given this function, and then it wants us to find the equation of the tangent line to the graph where x exists here. We will have something like this. Oh, wait. We will have something like this. Okay, we'll have something like this. Or if the question wants us to find the equation of the tangent line where x is at this point, we have to find the equation of the tangent line being here. Oh yeah, being here like this. But now, what the question asks is that it wants us to find the equation of the tangent of the line of the tangent line to the graph of f at the point where f of x equal to 0, which means that the gradient of the tangent is completely horizontal. It's completely 0. Okay, it's completely 0. So we have two tangent line which is completely 0 by looking at this graph, and this question basically wants us to figure out the equation for these two tangent lines where the gradient is completely 0. Okay, so let's differentiate this equation. We get 6x squared minus 5, and it wants us to equal to 0, which means that the gradient of this function will be 0. So 6x squared minus 5 equal to 0, and then that will leave us with 6x squared equal to 5, x squared equal to 5 by 6, and then x equal to plus or minus negative 5 by 6, resulting in plus or minus 0.91. That means that we have this general graph, since it's a cubic equation like this, and it wants us to find the equation of the tangent line where the gradient is 0, which means it's completely horizontal. Oh my god. Here, by looking at this graph, we see that there is two potential equations. There can be two. We can come up with two potential equations. And by calculating this up to this point, we have learned that the x value where the gradient of the tangent line is 0 is 0.91 and negative 0.91. Okay, so we will substitute these values into the original equation. 1 is equal to 0.91. It will give us with f of x equals to, we get a value of 4.04. Okay, it means that the y value that we get from substituting these values is that we get 0.91 comma negative 2.04, and then negative 0.1 comma 4.04. So if we have to come up with the equation, we have to write in a form y equal to mx plus c. But because for this question we are asking for the tangent line which the gradient is 0, and will be 0, so this whole part will be excluded, which will only result in y equal to c. So here in this case, we get two equations, y or f of x equal to negative 2.04, and then f of x equal to 4.04. And these are the equations that they want from this question. Alright, so this ends my video for prerequisites and review for this chapter, and then later on we will be diving deeper into the actual lessons that we will be learning in the chapter for curve sketching. See you guys later.